Hello everyone, welcome to this video where we'll be looking at some of the design optimization within S-Timber. So I've got this example here where we have a timber structure. It's supported by, basically we have timber framing that is supporting a panel, and these panels here are actually defined as area load panels. So just to introduce this a little bit more, we have different span directions set up in each one of the panels. So one panel just spans this area right here on the left hand side, and the other panel on the right hand side has a different span direction. And what we've done is we specified a long one direction span that basically spans the long direction of the panel, and it's shedding those loads that are applied to this panel to each one of the members on each side. These are area load members. So we can see the direction here is indicated basically by the edge of this tributary area, which is showing that any loads that land in this area here are going to be shed to this beam, and any loads that are applied to this area here are going to also be shed to that beam, and the edge beams are going to have half of the tributary area. On the other side, however, we've got a two-way span, so you can see the tributary areas look a little bit different, and naturally this is going to lend itself to having different member loads assigned to each particular member. If I look at the finite element view, I can actually display the member load and how they're set up. So we can see that on this far end here, we don't have any member loads on this member, but we do have member loads on these longitudinal beams, as we can see in the x-axis. And all the members on this side have member loads of varying magnitudes. So our goal is to analyze and design this structure, and in order to facilitate this, we need to set up design groups. Now, design groups are important for allowing us to design in an efficient way. Naturally, it's possible that in this type of arrangement, we're going to have different utilization ratios for each one of our members because the loading will be a little bit different throughout the structure. However, it's unlikely that the builder or even us as the engineer is going to want to assign different section sizes to each individual member. It complicates the the procurement of all the materials and also the assembly on site, amongst other things. So to make it easier on ourselves, we can set up design groups and specify groups of members that are going to have the same cross-section size regardless of those loads, meaning that that group of members might have different demands, and whatever member has the highest demand within that group is going to dictate the choice of section used for all of the other members in that group. Right now you can see that I've got the same section assigned for my columns and beams, and it's just a small glulam 80 by 114 millimeter section. So what I want to do first is I want to specify my design groups. I'm going to go to the Define menu, and here I can go to Design Groups, and I can click on the Add button, and we can specify a design group. So I'm going to start by defining a name. So I'm going to call this one column, and I'm going to just make sure that the column member type is slit. I'm going to choose the material type, which is glulam, and I actually already set up some section lists. Basically, these are just subsets of the cross-sectional database, in this case here the glulam database, that I'm going to be considering for design. So I'm going to click on the column section list. And what I can do, I can actually just maybe explore this a little bit more. So under timber, I can see that I have two different IDs. I have the column section list and the beam section list. And I've just done this just to set up some variety. So I've grabbed them from the glulam database. And basically, I've selected a subset of each one of those section databases to be considered for the section optimization. So I'm going to assign that column section list to my column design group. And I'm also going to go with my starting section size of glulam 80 by 114. We could assign this differently if we wanted to. I'm going to click Apply. I'm going to create two more. I'm going to create a design group, and this one here is going to be for my beams, and it's going to be called X direction beams. Naturally, the member type beam works here. The glulam material type works, and I'm also going to select the beam section list and the, again, default section size that I'm starting with. Now this again could be any other section that we wanted. I'll click Apply, and then once more, this one is going to be called Y direction beams. Material is going to be glulam, and the beam section list, and again my starting point for my arbitrary section here, I'll click apply. So now I've got these 3 different design groups, and it's up to me now to assign these to each one of my members. This might be easiest to do through the framing view. So I'm going to start by just defining my column section views, or my column selection set rather. Using the selection tool, I can just right click and drag around the members I'd like to select, my 9 columns here. And under this selection set, I go to members and I find the design group field where I can then say that this is a column. It's in the column design group rather. Now I'm going to proceed with the next set of sections. So just left click to select these X direction beams. And I'm sure by now you can guess what I'm going to do. I'm going to apply this design group. And I'm going to do the same thing in the Y direction as well, holding down Control just to make multiple selections. This one will be in the Y direction. Now again, the reason I'm separating these into different groups is because I will have different loads on the X direction beams versus the Y direction beams. So naturally, they could end up having different section sizes, and if I made them all the same section size, we might end up with more material than we need. Now that's obviously a cutoff in terms of how much granularity we have in our section groups versus how much material we want to save, because there is a double-edged sword involved, but it does allow us to study this in a more custom way. You can certainly set these up in any way you like. So with this done, let me first start by actually going ahead and running an analysis in CodeCheck. So I'll click on CodeCheck, and I'm going to run a linear static analysis alongside a CodeCheck. And here I can see I'm getting my utilization ratios. So this is showing me basically the governing utilizations, and specifically it's showing me a plot of all the member bending plus axial utilizations for the members in my model that happen to be the code check that governed my design checks. And I can actually study the whole details of the design as well here on the right hand side. I can see my design output windows including the utilizations for each different code check that's been appearing. So I have member bending plus axial as a governing, member bending, member deflection, two-way bending, and so on. So you can see here that they're kind of decreasing in utilization as I go down the list. And it's possible that some members are failing more severely for some code checks than others. So if I look at the member bending, for example, I can see here that, again, it's still these middle beams, which makes sense. They have the most load going to them. Deflections as well, they have a lot going there as well. And because we're all using the same section sizes, I suppose we're going to notice this trend for most of these cases. But with that said, let's go ahead and, armed with the knowledge that our sections are over-designed, or under-designed rather, overutilized, we want to go ahead and select some new section sizes. And we want the software to actually do that for us. So I'm going to go to the Run menu, and there's this Design menu that I can then click on Timber Member Design. And I can say Run Design. This allows me to set up my timber design here, where I can choose, I can see all my design groups. I can choose which ones I want to consider for the design. Maybe I want to ignore my columns, for example, and just optimize my beams. I can also choose what criteria to consider for my optimal section size. If it's the one with the lowest criteria, or lowest cross-sectional area rather, or lowest moments of inertia or whatnot. It's totally up to us what we decide to do. And of course, we can even further refine or define our design groups here. I'm going to click on the Run button and run all 3 of these design groups for their member design. And the analysis is completed. And you'll notice right away we don't really see any differences. But what we can do is we can go to, well, actually the best place to look might be actually in the spreadsheet view. So if I click on this spreadsheet window, and there's this design field. Here I can open this up and I can click on member design. And under member design, I get a tabular explanation of the results that came out of this design. So first of all, it's sorting by design group. It's showing me the current section that's been assigned, which is again, is that starting point that glulam 80 by 114 millimeter section. And then it's showing me the design section, basically the one that STimber has found would work best for my application. So it's showing me the original utilization was ranging from 3 to 5 to 1. Basically all the design groups had at least one failing member. And with this new utilization being much lower, we're able to come up with a better design. Now we could say, okay, let's go ahead and use these design sections, or we can even override the design as well if we wanted to. So if I wanted to say, well, let's go ahead and this is a little bit low of a utilization for me. Let's override this design. Now I can go in and I can choose a different section that might meet this criteria. In this case here, it's actually the smallest one in the list of sections I've allowed it to explore. So I would need to expand my design group section list in order to consider other sections. But let's just say, for example, here that we did want to look at other sections. I could consider this glulam 80 by 190. And you'll notice when I select that section, the design utilization has changed. So it's actually updating utilization based on what I selected. Let me go back to the glulam 80 by 152 and just keep this as is. And what we can also do is under the run menu here, I can go to design again, Timber design, and I can say, let's use the design sections. Let's use the sections that STimber has found for me. And I just want to apply them all, so I'll click apply. And it's updated the model for us. Let me just shrink this down. And you can see, first of all, visually, there's a clear difference in the section sizes that are being used compared to what we had before. So I can left click on one of these and I can see that it's a glulam 80 by 228. Maybe I'll look at the framing view and I can see what's being used. And I could even run the analysis and update the results based off of the change in stiffness and mass and so on that's taken effect. Now this same type of design is also available and design checks as well for connections. So if you're curious about that, we have another video on this topic. And if you have any questions, please feel free to reach out. We'd be happy to help.